So first of all, MIDAS, as was pointed out by Eric Mickelson a few minutes ago, is really the nexus, the focal point for data science, education, research, extramural programs, corporate outreach, faculty development, and so forth on campus. And so we provide a forum for networking among the various areas on campus that depend upon data science infrastructure, data science analytics, and data interpretation and visualization in order to perform their science, engineering, business, educational, or other types of activities. So that's where we sit, and this is part of our main mission is indeed to foster data science and the practice of data science in both the context of the sciences, engineering, and health, and other areas. So I'm going to show a few snapshots of some of those areas that are going strong at Michigan at the present time. We've had, of course, over the past years, a realization that the volume of data has been increasing with leaps and bounds. The variety of that data has allowed us to do things that we weren't able to do previously by applying analytical tools to extract information from data sources, which lead to the ability to predict and track and explain phenomena such as air pollution and the provenance of air pollution, the effect of air pollution on health, and using novel sensing modalities such as social media data and cell phone localization data. Folks in the College of Engineering, Civil Engineering, Electrical, Computer Engineering have been developing methods for making sense of this data and using things like non-negative matrix factorization to extract the kinds of information that would enable one to predict the effects of air pollution in modern city and urban rural environments. Another area is in the transportation. Autonomous connected vehicles is a main theme of our campus. We have another center called the Mobility Transformation Center, which is on North Campus. And it runs M-City, which is a small sort of micro-environment for checking autonomous vehicles. There are, of course, many impacts that autonomy, connectivity has on society. Safety, improving safety through autonomy and controlled environments, systems of public and private transportation, provides the ability with sensing and visual analytics for data science to come in and help to redefine transportation as a service and as a necessary economic driver for economic health. In education, we have many activities that are going on currently within the schools of education, LS&A, and here the School of Nursing in particular, which use analytical techniques to derive patterns of learning, which can be used proactively to affect outcomes in a positive way, where those patterns can be taken from data collected from traditional sources, such as student performance in courses, in addition to clickstream data and other types of data that's provided, for example, by the predictive analytic reports, which has anonymized records for over 2 million students. And then water quality monitoring, we have in the School of Natural Resources activities that have dealt with trying to track algae blooms, which have led to 500,000 people having to go to bottled water in the past couple of years in Toledo and outlying areas, and sampling over the Lake Erie to track and predict these algae blooms is a very difficult problem because you don't have the ability to sample everywhere. It's somewhat similar to the political polling data that has led to problems in the predicting elections, as we are definitely familiar. So these are some other examples from health that deal with the physiological signaling analysis from the medical school, where you're looking at traumatic brain injury and the ability to fuse many different types of data from the ICU into a system where you can use data analytics to minimize false alarms and maximize sensitivity to things like sepsis and issues of cardiac or respiratory failure much more quickly and efficiently than if you just have eyes on the screen. Integrated personal omics profiling is another area where data has enabled us to look at longitudinal analysis of subjects that are under a exposure perturbation by a flu virus in this particular case, and that allows us then, using a variety of techniques, analytical techniques, including regression and machine learning methods, to predict disease over time and stratify populations in terms of their susceptibility to disease based on many different types of omic assays and physiological risk band assays and other behavioral types of data. Epidemic monitoring in the School of Public Health is another example where we have the ability to use social and news media in addition to the standard CDC hospital death reports to combine that data to better predict the onset and spread of epidemics and design new vaccines for the next seasons. And then finally, I show here an example from lesson A, where obesity and smoking reinforcement learning and behavior modification techniques have been used in the context of a smartphone app that uses data science methods of prediction and reinforcement learning to send signals to stimulate, say, movement for obese subjects, so that through mobility they can maintain their targets on exercise. Now, accompanied with the explosion of data and the opportunities that variety of data is offering, there's also been an explosion in the number of software packages that enables the analysis of data if one can make sense of this very large ecosystem of software. And that's becoming more and more difficult as the number of software packages is increasing. On the right, I show a trend, an exponential increase in the number of R packages. R is, of course, a tool that allows one to implement machine learning and statistical and mathematical methods for large-scale data analysis, one of the most highly used tools in the field, and it's been increasing over the years at a very high rate. Unfortunately, if the number of packages increases at the same rate as the volume of data, we're really not offering the user community a viable tool that's generalizable and has a single dashboard, if you like, for being able to analyze complex data. So how do we handle data at this type of large scale, where now we have to deal with the user as a person who has to consume data in a finite and manageable fashion? Well, data science offers the methodologies in terms of data analysis, in terms of data management and data collection, to basically maximize the value of data without effectively overwhelming the user with complex data that cannot be easily visualized or made sense of. And so the engineering part of data science is designing a data decision pipeline, which takes data at the input and where that may become from cloud or local storage or sensing on a vehicle, and then passes it through a sequence of cleaning and integration and modeling and analysis blocks to the visualization with human collaboration throughout this process. So this is the dream, if you like, of federating and making coherent this set of packages that has been exponentially increasing, putting it into a framework or a pipeline where we have common interoperability between all of these packages is a principal goal of MIDAS. And indeed, dealing with this variety, volume, velocity, veracity, and value throughout this process, we believe is the only way to allow us to proceed. So the technical challenges can be addressed by realizing that MIDAS cuts across many different disciplines. Mathematics, where data is considered as a abstract matrix or a functional representation, and many different types of methods of geometric analysis, convex optimization can be brought to bear to build analytical tools, to understand data and apply those tools to develop new algorithms in natural language processing or machine learning, graph theory, and so forth, that computer scientists can help to translate into outcomes that can then be evaluated using statistical procedures where you look at a model for the random sampling, the bias sampling in algae blooms, for example, and how that impacts the veracity, the replicability, the reproducibility of the analytic engines. Information science deals with, of course, the interface to the data, which brings the human into the loop through data curation, sharing and reuse, human-computer interaction. The engineering of the system, of course, assures reliability of that pipeline, and it's the ability to scale that pipeline to a global scale where you can deal with many different types of data with a single paradigm for system-level pipelining of operations. And then physics, of course, that models as a natural phenomenon the types of data and structures that exist behind the data that can lead to the understanding of the provenance and physical mechanisms that lead to data generation. So as Eric explained, MIDAS is a university-wide institute. Under ARC, we live with consulting services, technology services, and computational science to further the data-intensive computational research that is going to and is presently affecting the educational and research and corporate partnership environment here at Michigan. This just shows some of the areas within MIDAS that we're going to talk about as we go through. We have 202 core and affiliate faculty at this point. We are offering 4 challenges thrusts. We have U of M faculty slots that are for both existing faculty, and we're recruiting 12 new faculty, of which we've filled 2 slots for core faculty, which you will be introduced to those faculty in a few minutes. Now, MIDAS can be viewed in terms of its interaction and impact on the local to global scale. And the local scale of MIDAS is that we really serve the 19 schools and colleges within University of Michigan. As I said, the focal point for answering those important questions about how to deal with large amounts of data to extract information for positive and reliable outcomes in terms of the analytics. So we extend across the campus all the way from the athletic campus, where we're looking at exercise and sports science, to North Campus, where we're looking at, with Michigan Institute for Clinical Health Research, at issues such as I was showing with the ICU data. At a little more macro scale, we are 3 campuses. U of M consists of the Flint Dearborn and Ann Arbor campuses. And so this institute has been operating with these campuses to involve them in the Southeast Michigan in all of the aspects, education, research, outreach, that MIDAS has going. At the macro level above, we have the Midwest Data Hub, which you'll be hearing a little more about, which connects Michigan to several Midwestern universities in a NSF-funded regional data science development initiative to increase the impact and partnerships between public and private institutions. And then we have, at a national impact level, our partners on the External Advisory Board, MIT, Harvard, Columbia, University of Virginia, ASU, that are helping us to develop open data to enable open science initiative. And then at the macro level of the global impact, we have several partnerships that are either in process or have been established through memorandums of understanding, both with Asia and with Europe and with Israel. So with that, I'm going to pass the baton to my co-director, and I think you're all set to...
Yeah, I'm ready to go.
Yep, great.
As Al mentioned, and Eric before him, we've got core faculty. The core faculty come from existing faculty that we brought around the schools and colleges in Dearborn and Flint. And right now, here's our core faculty. You can see they're spread right around the disciplines, and we're very grateful to Anna for her leadership coming from mathematics to bring our faculty engagement and recruitment committee together. You know, here's a snapshot of our affiliates, and of course what we're trying to do is, you know, lump them into groups that are disciplinary in nature or applications focused, and that's really worked well. They're growing from the bottom up, and we're aligning them with our challenge initiatives, both current or future ideas involving our challenge initiatives, and it's really wonderful to see this all pull together. You know, here, you know, we have, as Al mentioned, we have a dozen recruitments going on externally. Last year, we were delighted to get Zenki Wu, who's here, around here somewhere. Make sure to meet him. Coming in from Hopkins, Scott Seeger's laboratory at Public Health, and joining the Department of Biostatistics and Public Health. Mert Palanchi's coming from UC Berkeley, and will go up into engineering at ECE and be working closely with Al. And this fellow here is fantastic, actually, coming into BME and also in the medical school in DCMB, and will be working with MIDAS as well. You know, one of the things that's really delighted us, and we're so grateful to Northrop Grumman for their sponsorship, is our seminar series. And we've been able to bring luminaries from across the world coming in. Here's just a snapshot of some of them. I think choosing Friday at 4 o'clock and serving refreshments has helped. But nevertheless, it's just been absolutely exciting to hear from the world's leaders. And this has, you know, enhanced our ability to establish these national and international partnerships that Al just talked about. You know, we do have a role in education. As an honest broker in education, we're involved in helping to pull together the undergraduate and now emerging graduate programs in data science across the campuses. We're very grateful to Ivo Dinoff from the School of Nursing for his leadership as Associate Director of Education and Training. We've established an already successful graduate certificate in data science, which now currently has about 45 enrollees. And it's been fun. I've been working with them as well. It's been a lot of fun to meet them. They're from all over campus. One of the ideas and things that's emerging in partnership with our Academic Innovation Unit on campus is bringing together the MOOCs in data science. And in red here are MOOCs that have been developed by core affiliate faculty members in MIDAS and complementing others across the campus. And so a whole set of MOOCs are pulling together and are available for externally focusing our capabilities to the outside. And a number of our students are taking advantage of this, and a number of partners are taking advantage of this, like, for example, Sandia National Lab and other places. So this is really great. And Ivo and his data science MOOC is trying to pull this all together into a coherent whole. One of the funnest things for us, I think, was the MIDAS Summer Camp, which was a very successful, for Al and I it was a lot of fun, and Raj, our leader, we're all Fourier transform geeks at the end of the day, so it was fun to, take that to the high schools and look at it from a data science perspective. Next year, we're looking at summer camps in Detroit and in Ann Arbor, related to, our partnership with Athey, the Sports Science and Analytics Group, and we'll be looking at the role of data science in sports. MIDAS, we've mentioned them a couple times already. Here's the group under the leadership of Jake Abernathy and Eric Schwartz. This is a fantastic group that's working with the Kaggle capabilities, and from the bottom up is doing great things to help us understand what's happening in Flint and a lot of other challenge initiatives. Here's a little more on that. We've got a lot of press. We've been helping to organize, support, and promote, and actually participate in workshops all across the campus and sometimes across the world in terms of our partnership with SJTU in Shanghai. Both Al and I visited, and now we have 8 joint projects going with SJTU, where we have a faculty member at Michigan and a faculty member at SJTU participating in health and environment projects with data science focus. Several others. So here's one, the Claude Shannon Centennial Symposium. Claude Shannon, of course, the father of information science, was an undergraduate graduate. He's a Michigander, and he graduated from our engineering college. And we had a 100-year celebration. Al and Dave Newhoff and others led that, and it was absolutely phenomenal, and MIDAS supported it and helped pull it off. It was really great. This here is our mantra, where we have methods, cross-cutting methods that provide the basis for data science activities across the campus with vertically oriented, cross-cutting application initiatives. And we have our 4 challenges in learning, analytics, transportation, social sciences, and health, and future challenge thrusts in the future. And here's the facts in terms of the 4 that have started, the 4 that will be launched here in December, and the amount of support. The key is interdisciplinary teaming. You gotta have more than 3 schools and colleges participating. Last night at the dinner, someone was talking about 7 schools and colleges participating. It has to be coherent, it has to be strong in data science methodology, and it's gotta make impact and a difference and lead somewhere in terms of a center level activity. And those things are turning out quite well, and we're excited about this model. Here's some examples. Pascal van Heitenrijk, his name has been mentioned already, and he's involved in helping us transform our idea of transportation to the idea of mobility end-to-end, and using algorithmic support to understand how one can walk to the bus stop and catch the bus and get a shuttle and be dropped off and maybe get a car. There are many partners that are looking at this capability, and this is off to an extremely strong start here. And there's a big partnership with our Mobility Transportation Center, MTC, that Al mentioned, and in fact, now Pascal is chairing one of the pillars and is able to expose that capability to a number of the corporate partners that are participating in the MTC Leadership Circle. It's really a nice partnership between MIDAS and MTC. We're very happy with it. Also in transportation, Carol Flanagan, who's a core faculty member with us and is very active in the Midwest Data Hub, is one of the experts in safety. And God knows that safety is going to take a change in perspective with the autonomous vehicles coming up, and we're positioned to help with that, and her challenge is integrating that nicely into the future of our vision for data science and transportation. Stephanie Teasley from the School of Information and President-elect of the Learning Analytics National Society is leading the HOME initiative and is involved in helping tap into the many data that have been brought together at the University of Michigan and will help us understand how to better serve our students, understand when they are doing well, understand when they're in trouble, and help look for alternatives for students that are in trouble. And it's a wonderful project, and it's very complementary to the one that Radha is leading that has an aim to help makes the measurements and bring it all together in the aggregation and integration and ultimately analytics frame of applying data science to this heterogeneous data and helping to answer questions and understand where students are in their progression in school and help to intervene and make things better or actually in many ways, whether they're in trouble or not, to help advise them and guide them. I've mentioned the Midwest Data Hub a little bit already. The University of Michigan is one of 5 partners led by the University of Illinois. I stand as the co-PI and representing Michigan, and here are the goals of the NSF Big Data Hub. There are 4 data hubs in the United States. We're the Midwest Data Hub. And the places in red is where our special focus is. And in the neuroscience area, we were very successful in getting one of the coveted Spoke Awards from the NSF, led by Rich Gonzalez, in psychology and ISR, and George, who I see here in the audience, George Alder, and Ivo Dinoff, brings together all these Midwest groups to standardize and share data from neuroscience imaging. And, we also are going after spokes in transportation and advanced manufacturing and are delighted to participate in the Big Data Hub program with the NSF. Now, in terms of industry engagement, and we have several folks from industry that are either here or coming, and we'll have a chance to meet them at the lunch and at the dinners tonight. We've seen a lot of interest and a lot of discussions, and some major activities are already taking place. Eric mentioned Yottabyte's gift of $6 million to help us build the secure differential privacy environment to analyze data safe and secure, which is, of course, critical. Agilent, Coyote, Northrop Grumman, who's one of the sponsors of this conference, has been with us from the beginning. And Didi Kawaii from China is here and is participating with us now and hopefully in the future. And so this is a big area that we're pulling together. Karen Fireman, who is our liaison between External Advisory Board and the Industry Advisory Board, is here, and we've got lots of activities going, and we're very hopeful about this. This is proof positive that there will be streaming out. These are the attendees that have signed up, and they'll be coming in and out, and so that you can see that there's lots of interest locally and nationally and internationally in what we're doing, and there's been a lot of good discussions, and we've had lots of faculty interest and in startups in terms of projects. Here's our new home on the 6th floor of the Dennison building. Bob, you can see that this is all being gutted out, and there's going to be a lot of glass, and on the 10th floor there'll be a beautiful seminar and banquet and convention center there. We'll be up on the 6th floor of Weiser, and that'll happen next fall. And our focus is continuing our recruitment efforts both externally and within the UMich, launching the challenge initiatives fully and starting new ones, building off our Midwest Data Hub, and expanding our partnerships with universities, institutes, and center. And so if you look at where our future foci are specifically, we're in a position now to increase the number of extramurally sponsored interdisciplinary research projects building off of our start with the internal funding and interest on the challenge initiatives. We've got several teams underway. Develop the MIDAS ecosystem of corporate partnerships. You saw the logos, you see the start that we've got. That's a big partnership with the Business Engagement Center, the University Office of Development, and others. Working with our External Advisory Board to establish an open data collaboration across the leading U.S. data science institutes across the United States. We feel that this is a very important effort. This kind of happened spontaneously at our External Advisory Board call, where there was just a strong interest to see that being pulled together across the country and have MIDAS play a leadership role. It was really quite nice to hear that. And then we are committed to create a set of new challenge initiatives with corporate partners. We are very interested in privacy-aware analytics and cybersecurity. That is just the cross-cutting theme that has to exist to make data science real and safe for all of us. and responsive in terms of societal needs. Energy and the environment, and in the natural sciences. We've been in discussions with the various teams and the appropriate academic leaders across the university to make sure that we have our challenges spread across the whole of the interest spectrum that exists at the University of Michigan. And so I want to take this opportunity to thank our platinum sponsors, Northrop Grumman and DD, for their generous support of this conference and their interest in MIDAS. And Al, I'm ready to turn it over to you, and thank you very much for your attention and your interest in MIDAS. We really appreciate it.
This is sometimes the population of all U.S. economic units, establishment, enterprises. Sometimes it's the population of U.S. households. That's what we're really interested in. But actually, we have a data